My name is Ansh Chaber, and this is my Lab 1 on charge tapes. Some purposes of the lab were to see the interaction between charged pieces of tape, to determine excess charge on a piece of tape, and to determine the ratio of deficient electrons to the number of atoms on a piece of tape. These were some of the models and fundamental physical principles in the lab: Coulomb's law and gravitational force. These were counteracting forces in the lab. And Coulomb's law describes the electric force between point charges, while the gravitational force describes the downward pull on objects. The left figure shows the interaction between tape A and tape B, and how tape A makes tape B float, and the right shows the electric force on tape B from tape A, and in addition it shows the force of gravity on tape B, the counteracting forces. These were some of the main results of the lab. In the lab, there's a lot of text here, but basically what happened is pieces of tape were created and given charge. One piece of tape was laid on a flat surface, and additional pieces of tape were put on top of this base tape and ripped off to create charged tapes. These charged tapes, their interactions with different neutral and other charged objects was observed, and in addition, their interaction between each other, two pieces of charged tapes, was also observed. This is shown by figure 3 and 4 with the observation of a hand, and also seeing how two pieces of charged tapes interacted. Some main physics ideas were that objects can acquire a net positive charge by being rubbed, pulled apart, or touched on each other. This is what happened to the tape when they were ripped off from the base tape. Like charges attract and opposite charges repel, which is shown by Coulomb's law. And stationary objects have a net zero force. This is particularly important in the lab because it allows us to figure that the electric force on tape B is equivalent to the gravitational force on tape B, since the floating piece of tape did not have any upward or downward movement, since all the forces should sum to a net zero. Some of the assumptions you can make are that air resistance is negligible, that there's evenly distributed charge, and that piece of tape is a point charge, and this would make a more simple experiment. Charged tape interacted with neutral objects by being attracted to it, repelled other charged tape, and was attracted to negatively charged plastic pen. This is because charged tape is a positive charge, and any charged object is attracted to neutral objects. The other piece of tape is also positive, so it repels the other piece of tape, and it's attracted to a negative charge. In the experiment, tape B is the system and tape A and Earth are the surroundings, and this figure shows what happens to tape B once tape A is brought close to it. These are some of the data and calculations showing the charge on tape B, and also showing the ratio of deficient electrons to atoms. This was some of the code in its simulation. The code first shows the constants in measured data, and then it shows us the force in vectors, the upward and downward force, and then it creates the charge on the tape. It calculates that, and it calculates the deficient electrons, the number of atoms, and the ratio of the two. And lastly, it defines the tape objects and creates arrows representing the forces acting on tape B. Additionally, there are print statements to describe all of this behavior. This is the code and its simulation. The model and data use the same method to calculate the charge on the tape, so there's no significant differences in the data versus the model. Some sources of error could be inaccurately measuring tape length or width, which would create a different surface area, which would then result in the number of atoms being incorrect. Additionally, inaccurate measurements of separation distance would create error in the lab, and additionally, losing charge on tape due to handling could create error. Also, any of the simplifying assumptions do cause error, but they're assumed in the lab to make the lab simpler. If electrons had a positive charge and protons had a negative charge, nothing in the experiment would change, because although charges would be swapped, like charges would still repel and opposite charges would still attract. Also, it's important to handle charges as little as possible because hands are neutral, so the charge tastes when they come in contact with your hands. Some electrons can get transferred into the neutral object hand, and this can affect the interaction between each other. In conclusion, objects can be modeled as point charges. Charged objects lose charge, and electric forces play a large role in everyday interactions.